Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into your homework here in MRWC. And I'm talking about homework on 5E1, 2, and 3. Now, again, this is modified by me, so it's not exactly the activity in the curriculum. It's just reformatted, but it contains all the same concepts. And so, what we learned when we went through the activity, let's go back here in time. Let's go back to the main discovery part of the activity here, is that when we're multiplying numbers in trig form, okay, which is, let's write it in trig form. Trig form is where you have your complex numbers equal to r times the cosine of theta plus I times sine of theta. When you have numbers in trig form here, or complex numbers in trig form, and you multiply them, you simply multiply the moduli and add the polar angles. Okay, and then you simplify it using your knowledge of the unit circle or special right triangles, one of the two. When you divide complex numbers in trig form, you divide the moduli and you subtract the polar angles, and that's what we found out in the activity. So in your homework, you obviously have to apply those two concepts. Okay, so let's get right into it, all right, and show you how it's done. I'm producing this video because some of you guys needed help remotely, given the fact that we're online. So here we go. All right, so you can either use it as to check your work, or you can use this video to help you complete your work if you're not sure how to do it. All right, so we're given two complex numbers, z1 and z2 at the very top here. All right, so, and then we're going to work with them. In part A, we're going to multiply them, and in part B, we divide them. So let's take, in part A, we want to find z1 times z2. So we're going to multiply the moduli. Okay, so right here, okay, you'll see here in our formula that's multiplying the moduli. So multiply the two moduli, all right? And then right here, we're going to add the polar angles or the arguments. You can call them either polar angles, or you can call them the arguments of the function, however you want to do it, all right? Okay, so here we go. Let's write it out, z1 times z2. So that is equal to, all right, 4 root 3. So we have 4 root 3, all right, times all of this right here. Well, actually, wait a minute. Yeah, okay, actually, let me back up here. Let me identify the moduli first. I'm going to do a little color coding here. So the moduli in yellow. So 4 root 3, and on z2, the modulus is 2. So you identify them. So when you multiply the two complex numbers, you're going to multiply the two moduli first. All right, so I'll put this in blue. So 4 root 3 times 2, right? Times 2. All right, so you're going to multiply the moduli first, and then you're going to add the polar angles. Okay, what are the polar angles? Well, the first one's 315 degrees, and the second one is 15 degrees. That's one of the reasons why you need this identity, if you will, or this knowledge of how to multiply complex numbers in trig form, because if you're going to do this without a calculator, which means you have to use special right triangles or the unit circle, then you'd be stuck, because in the special right triangles that you know of, 15 degrees does not exist, and it's not here on the unit circle. All right, so this is going to come in very handy right now. Okay, so now I'm going to add the polar angles. I'm going to take the cosine of the sum of the angles. Now it's 315 plus the 15, so I have to add the two polar angles, 315 and 15. All right, and that, my friends, is 330 degrees. All right, so the cosine of 330 degrees plus I times the sine of 330 degrees. All right, so I first multiplied the moduli in front. Let me highlight that in yellow. Okay, right here. I'll simplify that in a minute. And then I simply add the polar angles, and I take 315 and add it to 15, and I got 330. Okay, that's all you do. Now you simplify. All right, so let's do this. All right, 4 root 3 times 2 is 8 rad 3, because 4 times 2 is usually 8. Okay, so you get 8 rad 3 right here. All right, and then you're going to have to simplify the cosine of 330 degrees, and you could use special right triangles, or you can simply use the unit circle. Now, 330 degrees is in quadrant 4. Okay, it's right here in quadrant 4. 330 degrees happens to be here, and the x-coordinate is your cosine of the angle here. So right here, The x-coordinate is root 3 over 2, which means that cosine of 330 degrees is equal to rad 3 over 2. And the sine of 330 degrees is equal to negative 1/2. Okay? So the x-coordinate is always the cosine of the angle, and the y-coordinate is always the sine of the angle. Always, always, always. Look at the very top. The x-coordinate comes first, and then the y-coordinate in any ordered pair, even on the unit circle. All right? And x is always the cosine of the angle. Y is always the sine of the angle, every single time. So I'm going to take these two numbers, bring them in. So the cosine of 330, as I said, is root 3 over 2, plus I times the sine of 330, which is negative 1/2. Notice the multiplication symbol. Okay, now we got to distribute through. Okay, so I got a root 3 times root 3. So a root 3 times root 3, all divided by 2, plus, and again, you have to distribute twice, right? A root 3 times negative 1, so which is a negative, so I'm going to bring down a minus sign. So I get 8 root 3 times negative I, all divided by 2. Okay, so 8I, negative 8I, or minus 8I root 3, all divided by 2. And then you simply divide by 2. And I don't know about you guys, but 8 divided by 2 is usually 4. Okay, so my end result. And then, oh, by the way, root 3 times root 3, well, that's root 9, which is just 3. So I get 4 times 3 here. All right, minus 4I root 3. And if you simplify that, you obviously get 12 minus 4I root 3. There you go, and there's your first one. So whenever you multiply complex numbers in trig form, you multiply their moduli and you add their polar angles. Okay. Now, when you divide numbers in complex form, you divide their moduli here, R1 divided by R2, and you subtract their polar angles. Okay? So here we go. So Z1 divided by Z2 is equal to the first modulus, 4 root 3 divided by 2. So 4 rad 3 divided by 2. All right, times, okay, the cosine of the difference. Now 315 minus 15, okay, it was obviously 300 degrees. So I take the cosine of 300 degrees plus I times the sine of 300 degrees. And then I simplify it. Okay? Okay, so here we go. So 4 root 3 divided by 2 is simply 2 root 3. Then the cosine of 300 degrees. Okay, now 300 degrees on the unit circle, okay, is right here. Okay, 300 degrees, which tells me that cosine of 300 degrees, all right, is 1/2. It also tells me that the sine of 300 degrees is equal to the y-coordinate, negative rad 3 over 2. Again, the x-coordinate is always the cosine of the angle, and the y-coordinate is always the sine of the angle. And there you go. You just bring your numbers in. Okay, now we know now that the cosine of 300 degrees is 1/2, and then plus I times the sine of 300 degrees, which is negative rad 3 over 2. Notice the time symbol here. It's I times the sine of that number. Okay, and then you simplify. Okay, so here we go. We're going to distribute through. Okay, so 2 root 3 times 1 divided by 2. So 2 root 3, all right, times 1/2 is 2 root 3 divided by 2. Plus, or actually minus, because a positive times a negative is a negative, because you got to distribute this thing twice, right? So a positive times a negative is a negative, so bring down the minus sign. Okay. Okay, and then you get 2 root 3 times root 3. So I'm going to put the I in the middle. Okay, so 2 times I is 2I, times root 3 times root 3. So 2 root 3 times root 3, that will become something here in a minute. I'll divide it by 2. Then you want to simplify. 2 divided by 2 is usually 1. Okay, and then you get root 3 here. Okay, that's simple, minus something. Now root 3 times root 3 is root 9, which is 3. So I just get minus 3i. Boom. Right there. And so what you want to do, guys, is just use the unit circle to your advantage. Print it off. Put a big bold on your desktop. Okay, unless you have knowledge of reference angles and the unit's special rights. If you want to use the 30-60-90 and the 45-45-90 and you want to use your knowledge of reference angles, you can do it that. Okay, you don't need this unit circle here. It's only for people that don't know reference angles and how to convert a quadrant 2 angle to quadrant 1 and then use your special rights, which is how I do it. But if you don't know that, then of course use a unit circle. Okay, let's move on. Let's go to radians here. Same thing. Here it says find the product. Okay, so here we go. Let's do it. So z1 times z2. So we have 6 root 2 times the cosine. Well, actually, let me speed up here. So here we go. We got the moduli. So let me highlight the moduli. The first modulus is 6 root 2 for the first number. The second modulus is 3. And since we're multiplying them, z1 times z2, you multiply the moduli first. So 6 root 2 times the 3 here. All right. Now you're going to add the polar angles. What are the polar angles, or the arguments? However you want to say it. Okay, they're polar angles or arguments, one of the two. The first one's pi 12ths and the second one's pi 12ths. And you want to add those. Okay, because we're multiplying the complex numbers, not dividing. So we're going to take the cosine here of the first angle, pi 12ths, plus the second angle, pi 12ths. All right, plus I times the sine of the sum of the angles. Again, you add the polar angles, pi 12ths plus pi 12ths. They happen to be the same. Okay, now pi 12ths is just 1/12. Okay, when you add 1/12 pi to 1/12 pi, you get 2/12 pi. Okay, you add fractions. Okay, let's go on the left side here. All right, so 1/12 plus 1/12 gives you 2/12. Guess what? And that's 1/6. All right, so if you just put a pi in there, you go 1/12 pi plus 1/12 pi is 2/12 pi, which is 1/6 pi, or known as pi 6. Okay, so we're going to add these. Okay, we have to add these polar angles, and we're going to get pi 6. All right, because 1/12 and 1/12 is 2/12, or 1/6 of a pi. You should do it in fractional form. All right, now we have 6 root 2 times 3, which is 18 rad 2. Okay, 6 times 3 is usually 18, times the cosine of the angle. And again, I did it on the side here. Okay, so when you add angles, 1/12 and a 12th is 2/12, but 2/12 is 1/6, and so you get pi 6, which is just an angle on the unit circle in quadrant 1. Okay, we'll do that here in a minute. So plus I times the sine of pi 6. So what is that? So let's talk about that here in a minute. So pi 6. No need to change the to degrees. All right, you don't need to do that. I mean, you can, but you don't need to. All right, pi 6 is here. It's 30 degrees. 180 divided by 6 is 30. Okay, but I know that this right here, the cosine of pi 6, is equal to root 3 over 2. I know that right here, looking at the unit circle, that the sine of pi 6 is equal to 1/2. Okay, there we go. All right, and now we just bring our results in. All right, so you use the unit circle to your advantage, and you bring your results in. So cosine of pi 6 is rad 3 over 2, plus I times the sine of pi 6, which is 1/2. Put the time symbol in. All right, now we multiply, we distribute. We've got to distribute twice. Okay, put the sound effects in. So you get 18 rad 2 times root 3, which is 18 rad 6, all divided by 2. Okay, plus 18 root 2 times I, which is 18I rad 2, all divided by 2. Look at the denominator. You've got to divide those both by 2. And then you simplify. 18 divided by 2 is usually 9. So my end result is 9 rad 6 plus 9I rad 2. There we go. That's Cartesian form. All right, last one. Given these two complex numbers here, all right, what is the quotient? Okay, so this first one here is the product. Okay, you multiply the moduli and add the angles. This is called a quotient. Okay, and now you divide the moduli and subtract the polar angles. Okay, so let's do this here. Let me just grab the unit circle here, make this a little bit. I need another one here, just to bring it down here. There we go. just so that I can enlarge the screen. All right, so here we go. We got to divide the moduli. Okay, so z1 divided by z2. You got to take 4 rad 2. Oh, let me highlight first. Sorry. The moduli is 4 rad 2 on the first one. It's rad 2 on the second one. And you want to divide them, because that's what we learned in the activity. Okay, when you divide the complex numbers in trig form, you divide the moduli. So 4 rad 2 divided by rad 2 times, okay, the cosine of the difference. And we got to subtract the polar angle. So cosine of 7/8 pi minus 1/8 pi. Oops, you know, there was a mistake on my, there was a typo in here. So let me fix the typo. Let me put this in red. This should be 7/8 or 7/8, 7 pi 8 here. Okay, and then both of these angles in the next one here should just be pi. So this should just be pi 8. Both should be pi 8. So in the first angles here, that both should be 7/8 pi. I should have changed that there. Okay, so we have to fix this one here at number 4. So both angles in the first expression here should both be 7 pi 8. Let me just make sure you guys are understanding here. So number 4 should be reading this right here. So z1 should be 4 rad 2, all right, times the cosine of 7/8 pi, 7 pi 8, plus I sine of 7 pi 8. They should be the same. Okay. Z2 should be root 2 times the cosine of pi 8 plus I sine of pi 8. There is a typo there. Okay, so fix number 4. Okay, so having said that, having fixed that, let's go ahead and continue now. Okay, so I want to take these polar angles. Let me highlight them in blue now like I did before. The first angle is 7 pi 8, and the second angle is your pi 8. Okay, you're going to subtract these, subtract polar angles. Or you can say arguments. So subtract polar angles, or you can say arguments. Some teachers like to use that word there. But it's a polar angle, it's the same thing. All right, and so here we go, let's do it. So we got 7 pi 8 minus pi 8, okay, plus I times the sine of the same thing. 7 pi 8 minus pi 8. Okay, so what is that? So 7 pi 8 minus pi 8. Now pi 8 is 1/8 pi. And as you guys know in fractions, 7/8 minus 1/8 is 6/8. So again, you just subtract here. So you get 6 pi 8. 7 minus 1 is 6. 7/8 minus 1/8 is 6/8. But that can be reduced to 3/4. So this is 3/4 of a pi, or 3 pi 4. Okay, so you subtract polar angles when dividing complex number. Subtract polar angles. Okay. That's angles right there, guys. There we go. All right, so let's continue here. Where are we at? Okay, so now we got to bring our results down. So let's do that. Okay, so simplifying a little bit. Root 2 divided by root 2 is 1, usually. All right, so this is equal to 4 times the cosine of 3/4 pi plus I times the sine of 3/4 pi. So let me highlight that. So I just subtracted the angles, the polar angles, and I've got these polar angles in here, and now we just need to use the unit circle here and get some values. Okay, so let's do that. Let's find 3/4 of a pi. Now 3/4 of a pi, whoops, is in quadrant 2. This is a quadrant 2 angle. Quadrant 2 is up here. Oops, 2. This is quadrant 1. Quadrant 2 is here. Okay, quadrant 3 is down here, and quadrant 4 is down here. All right, quadrant 4, 3/4 of a pi. Now, 3/4 of a pi happens to be the same thing as 1/35. All right, and I know by looking at this right here that the cosine of 3 pi 4, all right, is equal to negative rad 2 over 2. All right, And the sine of 3 pi fourths is equal to positive root 2 over 2 by looking at the triangle. Remember, the x coordinate is always equal to the cosine of the angle. The y coordinate is always equal to the sine of the angle. Okay, so now this whole thing is equal to negative rad 2 over 2 in the diagram. And this expression here, sine of 3/4 pi, is simply positive root 2 over 2. Okay, now we just bring everything down. So we have 4 times negative rad 2 over 2 plus I times root 2 over 2. And then you distribute twice. So what do we get? So 4 times negative rad 2 is negative 4 rad 2, all divided by 2, plus 4I root 2, just multiply. 4 times I times rad 2, 4 times I times rad 2, all divided by 2. And then you simplify. Negative 4 divided by 2 is negative 2, so you get negative 2 rad 2. I just simplified right here, okay? And then 4 divided by 2 is 2, so you get 2I rad 2. So plus 2I rad 2. And there's our end result. And that is Cartesian form. Okay, so let's bring everything in here. So let me see, that's your homework there, number 2, 3, and 4. All right. So what I want you guys to do is to, after you correct your work and go through this here, I want you to resubmit it. And I don't care what score you had, I'm going to raise your score. So as long as you redo it and submit it and show me that you learned something here, I will be happy to raise your homework score from whatever it is to, well, a little bit higher depending on what you do. I've got to see it first. So every assignment is 10 points. So if you didn't do this, you probably got a 6 out of 10, which is obviously not good. All right, and so correct your score or correct your work, resubmit your grades, or you resubmit your work, excuse me, in Canvas, and then learn from it, okay? All right, hopefully that helped you guys out. I'll see you in my next lesson. This is Ainsworth. All right, bye-bye now.